Well, here we are. We're back together to get a little bit more work done on proofs. So with some more proofs to go and our eyes staring at like, what the heck? Let's get these proofs down pat and a little better understood. This is the 12th lesson. Our agenda for today, we're going to go over some review questions like we always do. We're going to work on some more proofs, and then there is a quiz later in the period. Okay, let's start the review questions. A little stop and start action. I'll give explanations afterwards. Go ahead. Okay, so in this particular case, because it's an isosceles triangle, which we know because of these marks here, the angles have to be equal. So the x in the base and the other x angle for the base angle plus the 80 for the vertex at the top have to add up to 180. 2x and 80 is 180. Subtracting the 80, 2x is 100 divided by 2, and we get 50 degrees is the value of x. Here we go. Stop and start again. These are isosceles. This is an isosceles triangle, and those are the legs. Okay, so since they are the legs, we know they're going to be equal in this isosceles triangle. That we also know because these base angles at the bottom are equal. A little bit cut off, but you can see the marks saying they're equal. And the sides across from equal angles will always be equal themselves. So subtract the 2x from both sides. You might be tempted to subtract the 5x, and that does work, but unfortunately it's going to put more negatives in the problem, and we want to avoid negatives, so you're much better off subtracting the 2x. Always subtract the least number of x's. Okay, so that gives me 16 is 3x plus 1, subtracting the 1, 15 is 3x, divide by 3, x is 5. And that is your correct answer for this one. But they ask you to find the length of a leg. The length of the leg is not 5. The length of a leg is 2 times 5 plus 16, which is 26. And just to make sure I did it right, I tested the other leg too. 5 times 5 is 25 plus 1 is 26. Okay, what's the longest side of the triangle? And I think that, with this whole shortest side, longest side kind of thing, I think there are 2 questions on your upcoming quiz that deal with this. So, good question here to practice. Okay. So these 2 angles, 61 and 49, they add up to 110, which means the missing angle is 70. And remember, the longest side is always across from the biggest angle. The smallest side is across from the smallest angle. Since this is 70, the longest side is yn. You also have something like this on your quiz coming up as well. And by the way, just because I don't mention something doesn't mean it's not on the quiz. It just so happens I made the quiz a few hours ago, and some questions are more freshly on my mind than other questions. So this is one that's definitely freshly on my mind, where the measure of an exterior angle, like angle UTB, is equal to the sum of the 2 remote interior angles, the angle at U and the angle at V. Stop and start. Okay, so the 7x plus 5, the one remote interior angle, plus the other one, 34, has to equal the exterior, which is 20x. So, combining like terms here, same side, same operation. The 5 and the 34 make 39. Subtracting the 7x, 39 is 13x. Divide by 13, x is 3. Okay, so we have a supplementary and a complementary situation here. Solve them both, and then we'll go over the answers to both of them. Stop and start. All right, so first, these 2 angles make a straight line, the 6n plus 13 and the 4n plus 17, which makes them supplementary. They form a linear pair. They are also adjacent angles, practicing adjacent meaning they share a side in common. So I add them up and I get to 180. They add up to 180 because they make a straight line, and a straight line makes half a circle. Combining like terms, that's 10n plus 30, because 13 and 17 is 30. The obvious is 6n and 4n is 10n. Subtracting 30, 10n is 150. Dividing by 10, n is 15. On the next problem, they don't add up to 180. They add up to 90, which is half of 180, and that makes sense because if I start here and go up, I'm halfway to a straight line, quarter way to a full circle. So the 2x plus the x plus 18 have to add up to 90 degrees. Same side, same operation. Combine the like terms with the x's. That's 3x plus 18 is 90. Subtracting the 18, 3x is 72. Dividing by 3, x is 24. Okay. Next up, the measures of two complementary angles are in the ratio. Take it from here. Remember how to handle ratio. That is also something you will be seeing pretty soon. Okay. So since they're in a ratio of 4 to 5, that means they share something in common. I do not know what that common thing is, so I'm just going to call it n. So 4n plus 5n has to add up to 90 because they're complementary. That's 9n is 90, dividing, and I get n is 10. But that's not the answer. It wants the smaller angle. The smaller angle is 4n, which is 4 times 10, which is 40. Here we go with an order from least to greatest kind of question. Again, all of these questions about longer side, shorter side, ordering, these are the kinds that you will definitely see twice on your quiz. You'll see them on homeworks. You'll see them on lots of different assignments. Okay, so first you want to find the missing angle. So the 86 and the 27 is 113. 180 minus 113 is 67. So the measure of angle A is 67. So the smallest side is across from the smallest angle because you want to go from least to greatest. The smallest angle is 27, so the smallest side has to be AB. Now 67, that's the middle size of these angles. So the side across from it, BC, is the middle size, and the biggest angle is 86, so AC is the longest side. Find all the missing angles. Keep in mind that one angle is 112. Go ahead. Okay, this is our parallel lines cut by a transversal situation. And we remember that all your obtuse angles are going to be equal to each other. So we have 112, 112, and 112. And then all of the acute angles are equal to each other. 68, 68, 68, and 68. Why 68? Well, the reason that it's 68 is because, for example, in the diagram, angles A and B make a straight line. Angle B and 112 that you're given make a straight line. So what happens is they add up to 180 because they make a straight line. So 180 minus 112 is 68. That's where the 68 comes from. But I think you knew that. All right, so that's just a mass of angles. Let's get down to just a few angles. Go ahead, give this a try. Of course, the lines are parallel. Okay, so since the lines are parallel and cut by a transversal, what we have here are alternate exterior angles, which we know are going to be equal. We can also recognize that they're both acute, so they'll be equal, or if I do drag and drop, they'll end up vertical to each other, so they're going to be equal. So therefore, 4x plus 34 will equal 7x minus 20. Subtracting the 4x, I get 34 equals 3x minus 20. Adding the 20, 3x is 54. Dividing by the 3, and x is 18. So there's a whole lot of review questions done. What did we talk about review-wise? Well, we did some isosceles work, remembering, of course, that in an isosceles triangle, two legs are equal, and the two base angles opposite those legs are also going to be equal. We reviewed parallel lines cut by a transversal, how all the acute angles are equal, how all the obtuses are equal, and how one acute and one obtuse add up to 180. We also did the specific case of alternate exterior angles, though there are others like corresponding, alternate interior, and consecutive interior. Next, we did complementary as two angles that add up to 90, supplementary, two angles that add up to 180. We reviewed the fact that the three angles of a triangle have to add up to 180, and we also talked about problems where you see the word ratio, angles are in a particular ratio, and that means use n, like the 4n plus 5n was 90. And then the longest side of a triangle is always across from the biggest angle, the smallest side across from the smallest angle, and of course, if we keep going with that, the middle angle is across from the middle length side. So that's a review of a lot of the kind of questions that we've covered so far. All of them? No, but a lot of them. Let's get ready to get into some more work, some more review questions, this time about parallelograms.